In section 1.1, we're going to be talking about chemistry and really what it is. So just as a quick and easy definition right off the bat, chemistry is just the study of what the world is made out of and how it changes from one substance or compound to another. That's what we're going to be talking about. Now, as we know from high school chemistry that you've seen before, the world is really made up of atoms. That's the building block of matter. And if we look at this little example from your textbook, we see how we zoom in at a very tiny spot of the bloodstream within a person, and we can see inside the red blood cells. And inside those red blood cells are these hemoglobin molecules, this collection of atoms attached in a very specific way, very specific atoms, types of atoms connected in very specific ways. Now, inside a hemoglobin, we have all of this kind of green ribbony structure in the background, which represents some connectivity of atoms that we're not really interested in because it's just the connecting building blocks. But then we have this little porphyrin ring type structure over here, which actually gives it the functionality of this particular molecule. And the functionality of hemoglobin, as you might know, is to transport oxygen molecules around the body. Now, an oxygen molecule is just two oxygen atoms attached to each other with a chemical bond. So they are atoms attached to each other. Carbon monoxide, however, is another molecule that can get involved with hemoglobin, and it can stick to the hemoglobin and move around with it and get transported through the body. But the difference is when you have just a carbon and an oxygen attached to each other, which is the connectivity and the types of atoms connected in carbon monoxide molecules, it sticks to the hemoglobin, but it sticks too well, and it binds into that site and doesn't allow oxygen to take its place. And when oxygen can't get into the hemoglobin and be transported in your body, effectively what happens is you then suffocate from lack of oxygen just because the carbon monoxide is taking its place and not letting go. Now, look at the difference between these two molecules, these two collection of atoms bonded together in a particular way. I have oxygen in both, but in carbon monoxide, instead of a second oxygen bound, I have a carbon atom attached to the oxygen instead. And it's just this little bit of molecular change, this little slight difference in what atoms are present, that gives us these vastly different properties in terms of whether it's going to be horribly toxic and we're going to need a carbon monoxide detector in my house in order to be up to code, or whether or not you actually have something that you need to live and breathe in all the time. So let's look at these molecules again. Let's look at carbon and oxygen attached to each other in carbon monoxide. And let's look at adding a second oxygen, which is carbon dioxide. Okay, so that's just a carbon, and it's attached to an oxygen on either side. And these are little molecular diagrams, and we're going to be using a lot of molecular diagrams throughout the semester. We actually have a carbon atom in gray and an oxygen atom in red, and they are bonded and held together. So that's what this little smushed together diagram represents. So the reason this is carbon dioxide, meaning two oxygens attached to a carbon, we show the carbon in gray in the center, and these two oxygen atoms smushed into it on either side. Now, carbon dioxide you actually breathe out, and is not all that toxic. I mean, in high enough quantities, you're not going to be able to get enough oxygen into your system, and that can cause problems. But it doesn't have nearly the issue that you would have with carbon monoxide, which actually gives you a very high level of toxicity in very small doses. So now, looking at these, what's the difference? In the second molecule, I have a different ratio, and I have a different connectivity. I have this oxygen attached on both sides of the carbon versus an oxygen only attached on one side of the carbon. And this is actually what leads to this being such a extremely different set of properties in actuality. Toxic, carbon dioxide, not so toxic. And well, here's another example. And we kind of have this idea of safe versus not safe being sometimes a very subtle difference in the molecule itself and the atoms that are present and their connectivity. So kind of just like we have carbon and oxygen in different ratios giving different properties, different chemical properties to that system, we have here oxygen in red attached to two hydrogens in white, and this is the molecule water, H2O. Here we have two oxygens attached on either end to hydrogens. There's lines representing connectivity between the atoms and the letters representing the different atoms. And here we have H2O2, which is hydrogen peroxide. So hydrogen peroxide, while useful perhaps for disinfecting and killing germs, it is also going to kill you if you drink it in any kind of quantity. While water, you can drink water all day long and you're going to have no serious effects. And all the difference is that we have a difference in connectivity, oxygen to oxygen here instead of oxygen to hydrogen only. And we have a different ratio. We have two hydrogens and two oxygens versus in water we have one oxygen to two hydrogens. So this difference is what leads to the difference in chemical properties and physical properties as well. So we want to remember this, that this whole world is made up of atoms, and their connectivity and their ratios are what lead to the properties that we're going to be investigating and learning much more about throughout the semester. So that gives us a little bit of a more detailed description then of what chemistry is. It's the science that seeks to understand the behavior. Okay, so that's the properties and how it can interact with other substances of matter. And matter, of course, is just anything that's not energy, and we'll talk about that more in detail later. And we do this by studying the behavior of atoms and molecules.